Hi students, very good morning. Today in this lecture we are going to deal with respect to velocity of an electron in a particular orbit. Right students? Velocity of an electron, whenever it is, already Bohr has said that the orbital is having fixed amount of energy, it is moving with a fixed velocity and a fixed radius. So we have calculated the radius, we have calculated the energy, now we are going to calculate the velocity. We know that centrifugal force is equal to centripetal force. We know that Z square by R square is equal to mv square by R. Already with respect to radius thing, we will know that. Okay. Now we know that mvr is equal to nh by 2 pi R. If you subject R, you will be getting nh by 2 pi mv. Now you take this R value and you place here. So R cancels. So mv square is equal to Z square by R. You place this R value here. So that you will be getting Z square by nh into 2 pi mv. Okay. V cancels here, so that V is equal to is cancelled, VV is cancelled, so that 2 pi Z E square by NH. See, M cancelled, VV cancels. So V is equal to 2 pi Z E square by NH. So the formula of the velocity of an electron revolving in a particular orbit. See, what are the variables in this equation? 2 is constant, pi is constant, Z is variable, charge of electron is constant, n is variable, h is constant. So if you substitute all the values, you will be getting velocity is equal to 2.18 into 10 power 6 z by n. So velocity is proportional to z by n. Okay, in terms of meters per second. Okay, velocity is directly proportional to atomic number. Velocity is inversely proportional to the radius of an atom. So this is the derivation with respect to physics. Anyhow, the value is the same. Okay, let us take one or two problems with respect to this one. See, speed of electron in the first orbit of hydrogen atom. He is asking for the hydrogen atom. Okay, for hydrogen atom, Z is equal to 1. Orbit number he has mentioned as first orbit, so n is equal to 1. These are the things. And velocity, you know that 2.18 into 10 power 6 z by n. So let's substitute these values in this equation. So that 2.18 into 10 power 6 1 by 1, you will be getting the value as 2.18 into 10 power 6 meters per second. Second question is calculate the speed of an electron in the second orbit of helium plus. Okay, second orbit he is mentioning means n is equal to 2, and atomic number of helium, it is also 2, right? So 2.18 into 10 power 6 z by n, 2 by 2 cancels, so velocity will be equal to 2.18 into 10 power 6 meters per second. That is the way of calculating the velocity of an electron, students, right? And we have already discussed it with respect to energy. Now let us go with respect to atomic spectra. See, yesterday itself and the final session I have said. So he has taken a container with hydrogen gas, he is heating. So that what you will be getting? You will be getting particular color. Okay, rays are getting observed on the screen. Already we have mentioned some rays will be observed with respect to hydrogen. This spectra, whatever you are getting, it is called as discrete spectra as well as line spectra. Okay, if you are heating means whatever the rays, if you, instead of heating, if you pass the light, okay, all colors will not be observed here. The energy, whatever that is responsible for the excitation of electron from one orbit to other orbit, that will be observed. Apart from that color, all the colors will be observed on the screen itself. So what is saying that electron always tries to remain in the lowest energy level. So electron tries to return back. Okay, whenever suppose the electron is getting absorbed, see, assume that this is an hydrogen atom. If you pass light, what happens? It absorbs the energy, it gets excited to the higher level. But basically, energy tries to be in the lowest state. Okay, electron tries to be in the lowest energy state. So that what happens? It tries to return back to the original state. So that whatever the energy that has been absorbed, it is emitted out in the form of radiation. So basically, electron is present in the second orbit. By absorbing the light, it has got excited to the fourth orbit. But basically it tries to be in the second orbit only. Due to provision of providing energy, it has shifted to the higher energy orbital. Now what happens? It emits that energy and it returns to the background state. So that whenever it is getting back to the ground state, it emits the energy, whatever that has been absorbed. And that line or light you are getting, that is called as spectrum, that is obtained by emission spectrum. Okay, that light whatever you are getting or electromagnetic wave you are getting, whenever it is getting de-excited, that light, if you pass through a prism, you will be getting a spectrum. That spectrum is called as emission spectrum. Right, students? Take this question. An electron in hydrogen atom jumps from n is equal to 2 to n is equal to 1. Means from second orbit it is getting to first orbit. Find the energy wavelength of the emitter radiation. See students, you keep in this mind, E is equal to hc by lambda. I think you know this one. So generally you remember this formula, E is equal to h nu. H is nothing but Planck's constant, nu is nothing but frequency, and frequency you can write it as c by lambda, so it is equal to hc by lambda. Okay, and 1 by lambda you can write it as wave number, hc wave number. See, E is equal to h nu, frequency, nu is nothing but frequency, and instead of nu you can write it as c by lambda. Lambda is nothing but wavelength, and you can write it as 1 by lambda is equal to wave number. Okay, see, here itself I am explaining what is mean by frequency. This one, nu, means number of, see, like this you are having radiations like waves, right? Number of waves that are passing through a point in 1 second. You are giving a time 1 second and you are asking this rays to pass through this point. How many waves those are going this through this particular point in 1 second, it is called as frequency. Getting me? Number of waves, it may be 1 wave, 2 wave, 3 wave or 4 wave or some 1000 waves. See, number of waves passing through a point in 1 second, it is called as frequency, right? And what is mean by lambda? Lambda means wavelength. This is one crest, one trough. See, again, one crest, one trough, it is called as lambda. Okay, and what is mean by wave number? Means if you take 1 centimeter length, here one wave, 1 lambda. Here in 1 centimeter length you are getting 2 lambda. You may get 3 lambda, but you are not changing the distance. In unit length, how many wavelengths are there? That is called as wave number. Again I am repeating. Frequency means number of waves passing through a particular point in 1 second is called as frequency. One crest plus one trough, it is called as wavelength. And number of wavelengths in unit length. Okay, unit length, that is not 1 centimeter. You can take anything, 1 meter or one thing, any unit length. So number of wavelengths in given unit length, it is called as wave number. It is indicated with frequency symbol, upon frequency symbol a bar. Okay, so he is asking the electron getting from second orbit to first orbit. You know that second orbit energy is minus 13.6. You know general formula is z square by n square. So z is nothing but 1 itself because it is an hydrogen atom, by n square, it is 2 square. So that you will be getting minus 13.6 by 4. If you go for the energy of first orbit, it is minus 13.6 into z square is 1 square by first orbit. 1 square is equal to minus 13.6. So he is asking the difference. So what you should be getting? You should be getting E2 minus E1. Okay. If you calculate that, you will be getting. So delta E is nothing but E2 minus E1 minus 13.6 by 4 minus of 13.6. You will be getting plus 13.6 minus 3.4. So the difference in energy when an electron is getting shifted from second orbit to first orbit is 10.2 electron volt. Okay. Instead of doing all these things, you can remember shortcut way. You know that delta E is equal to h nu by lambda, hc by lambda. It is also equal to h nu. And instead of, you know that h is a Planck's constant. It is nothing but 6.625 into 10 power minus 34 joules or minus 27 eggs. And c is nothing but velocity of the light, that is nothing but 3 into 10 power 8 meters per second. Those two are the constant values, right? Only the wavelength is changing. So whenever the delta E in electron volt, lambda is in wavelength, this Armstrongs. Lambda is nothing but wavelength. Whenever this has been mentioned in Armstrongs, then you can use directly this formula because you have already, these are the constant values. After calculating that, you will be getting, see, simple number 1, 2, 3, 4, 5. Instead of 4, you take it as 7. So delta E, whenever it has been asked in electron volts and the lambda has been mentioned in Armstrongs, the direct formula is 12375 by lambda. So lambda is equal to 12375 by 10.2. If he has mentioned, see, he has calculated energy, right? Difference in energy. Okay, next he is asking wavelength. Wavelength means lambda is equal to, already you are getting delta energy you have got in terms of electron volts. And lambda, he is asking lambda whatever you will be getting in terms of Armstrongs you will be getting, that is nothing but 12375 by 10.2 Armstrong. That is the value of the lambda, right? So let us go for the calculation of delta E. En, energy of the nth orbit will be equal to minus 2 pi square z square m e power 4 by n square h square. If I want between it, the electron jumps from the second orbit to first orbit. Here only nth orbit. We have not mentioned which orbit it is existing. So E2 means minus 2 pi square, same value here also. Minus 2 pi square z square m e power 4. Here instead of n square, you will be getting n2 square, h square. E1 means minus 2 pi square z square m e power 4 n1 square h square. Delta E means what does that indicate? E2 minus E1. Delta E is equal to minus 2 pi square Z square me power 4 by N2 square H square minus in bracket E1 value. This minus is this one. E1 is basically you are getting in minus 1, right? Minus 2 pi square Z square me power 4 by N1 square H square. Right, students? Then delta E will be equal to 2 pi square Z square me power 4 by H square. This is the common term that I am taking from this side. So that I will be getting 1 by N1 square. So minus of minus. You will be getting plus N1 square. This one is minus 1 by N2 square. Clear? And I know that delta E is equal to HC by lambda. 2 pi square Z square me power 4 by H square. Bracket 1 by N1 square minus 1 by N2 square. Bracket closed. So if you send HC, whatever that is present here to this side, what it becomes 1 by lambda will be equal to 2 pi square Z square me power 4 by CH cube. 1 by N1 square minus 1 by N2 square. Okay. In this term, entire term, only variable is, only Z is variable. See, 2 constant, pi constant, M, mass of electron, charge of electron, velocity of the light, and H, Planck's constant. These are the constant things, right? Only the variable thing is Z. So, this entire thing has been taken as R. R into variable is Z square, 1 by N1 square minus 1 by N2 square, and 1 by lambda you can write it as wave number. And R it is called as Rydberg constant. R it is called as Rydberg constant, and the value of R is 109,678 centimeters inwards. Okay, no need to remember this one. You remember this value. 1 by R is equal to 911 angstroms. Okay, 1 by R, 1 by Rydberg constant is equal to, in terms of angstrom, it is 911 angstroms. If they ask a directly value, it is 109,678. Okay, see, you can remember in this way. 108, you know that ambulance number, so you can directly one number you increase, 109,678. 600 are the series numbers, right? Okay, in this way, the difference in energy. So wave number will be equal to RZ square 1 by N1 square minus 1 by N2 square. This is the term. This is the way you can solve with respect to physics by taking directly value, right? So no need to remember all the physics one. Only chemistry one is important for us. Okay, right. So what he is telling is the electron. Okay, the electron may jump from the highest orbit to the lowest orbit. The highest orbit may be 6th orbit, it may be 5th orbit, it may be 3rd or 4th orbit, 3rd or 2nd, okay, anything. But the electron is jumping to the 1st orbit. So from anywhere the electron jumps into the 1st orbit, then that is called as Lyman series. Be clear with this. From anywhere, it may be 6th, 5th, 4th, 3rd, 2nd. If the electron jumps into the 1st orbit, means finally the electron is reaching 1st orbit, then that belongs to Lyman series. From anywhere the electron jumps into the 2nd orbit, it is called as Balmer series. If it jumps into third place, means 3rd orbit, instead of representing in the circular forms, I have represented in the form of lines. Okay, 3rd one, it is called as Paschen series, means the electron is getting jumped from 6th to 5th. Don't take in the reverse condition. Okay, de-excitation only, not excitation. Okay, from higher energy orbitals to, then electron is coming into the lower energy orbitals. Finally, it is coming to 3rd orbit. So this is called as Paschen. This one is called as bracket. This one is called as Fund series. If the electron jumps into the 5th orbit, finally, it is called as Fund series. So from anywhere electron comes to 1st orbit, it is Lyman. If it comes to 2nd orbit, it is Balmer. 3rd means Paschen. 4th means bracket, and 5th means Fund. See here, already I have represented. Shortest wavelength is 911 angstroms, that is 1 by R value. 911 angstroms, it is the largest transition. Okay, shortest wavelength means largest transition. Longest wavelength means shortest transition, because energy and lambda are inversely proportional. Be clear with this. Energy, you know that E is equal to hc by lambda. If lambda is bigger, energy will be smaller. If lambda is smaller, energy will be bigger. Okay, right. See, for the first one, we are going to calculate this. What is lambda if the electron jumps from 2nd orbit to 1st orbit for hydrogen atom? He is asking the lambda value. So we know that 1 by lambda is equal to RZ square, 1 by N1 square minus 1 by N2 square. 1 by lambda is equal to R1 square. Z value is 1 because it has been mentioned as hydrogen atom. So 1 by 1 square minus 1 by 2 square. So it is 1 minus 1 by 4. So it is 3R by 4. 1 by lambda is equal to 3R by 4. It is not the value of lambda. If you take lambda, what will be getting? 4 by 3R. And you know that 1 by R value is equal to 911. Okay. 1 by R is equal to 911. So it is 4 by 3 into 911. So you will be getting 1215 angstroms. This is the first line of Lyman series. Means Lyman series means you should get into the 1st orbit. You are getting the first line from 2nd to 1st one. it may be third to first one, it is the second line. So here, whenever the first jumping of an electron from second orbit to first orbit, the wavelength in Lyman series is 1215 angstroms. In the same way, try to calculate for the second line for the same thing. 1 by r is 1 by lambda is equal to r 1 square, 1 by 1 square minus 1 by 3 square, because it is coming from the third orbit. 1 minus 1 by 9, so it is 8r by 9, 1 by lambda, lambda is equal to 9 by 8r, 9 by 8 into 911, so it is 1024 angstroms. So this is the second line of Lyman series. So second line of Lyman series, it bears the value of lambda, it is 1024. So what happened to the lambda? It has been decreased because the energy value goes on increasing. Right. Suppose if I take the infinity line, so it is r into 1 square, 1 by lambda square minus, somewhere it is coming, you don't know that orbit, it is 1 by infinity square. And you can neglect this one, 1 by infinity square is nothing but 0. So it will be r into 1, so 1 by lambda is equal to r, and lambda is equal to 1 by r, it is equal to 911 angstroms. This indicates, so what it is happening, if you are going on indicating the value of lambda is going on, it has happened to 911 angstroms. The wavelength is going on decreasing. If the wavelength is decreasing, what happens to the energy? It will be increasing. So it is coming from infinity, means it is a transition, transition means jumping. This is the longest transition because it is coming from somewhere, infinity distance. You see here, it is coming from the second orbit only. Okay, this is the shortest distance. This is the longest one. So this is the longest distance, means longest transition, you are having the smallest wavelength. For the shortest transition, okay, it is having the longest wavelength. Wavelength is longer, this is the shortest transition. Wavelength is minimum, so this is the longest transition. If transition is high, lambda will be less. Okay, right students, this is for Lyman series. So try to calculate for the Balmer series, first line, second line, as well as the infinity. Okay, so already I have done that. Check over this. Calculate the shortest and longest wavelength of Balmer series. Longest wavelength means it should be having shortest transition, so n1 is equal to 2, n2 is equal to 3, because Balmer series, the least one is 2 itself. So you will be getting r z square, 1 by 2 square minus 1 by 3 square, so it is 1 by 4 minus 1 by 9, 1 by lambda is equal to 5r by 36, and lambda is equal to 36 by 5r. So 36 by 5, and you know that 1 by r is equal to 911, so you will be getting 6560. So this is the shortest transition, means you are having the longest wavelength. And go for infinity, means the longest transition, r z square, 1 by 2 square minus 1 by infinity square, you will be getting r 1 square into 1 by 4 minus 1 by lambda, so it is r by 4, you will be getting lambda is equal to 4 by r, 4 into 911, you will be getting 3644 angstroms. Okay, so this is the longest transition, this is the shortest transition wavelength, this is the longest transition wavelength. So only Balmer series. So we have talked with respect to 5 series, right? Only Balmer can be seen with our naked eyes, as is in the range of visible region. So all the sets, whatever that I have discussed at the top, is that these things, Lyman, Balmer, Paschen, bracket, fund, we are only having up to here, and there is one more series that is called as Humphrey series, where the n1 is equal to 6. So n2 value for Lyman series, it can be 2, 3, 4, 5. From first to first orbit, it can't get. Okay, so these are the things. Second to 3, 4, here 2 means here 3, 4, 5, 6, because 3 means 4, 5, 6, 7. And in which regions they are appearing? Lyman appears in ultraviolet, Balmer in visible, Paschen in near infrared, okay, bracket infrared, fund far infrared, and Humphrey series also in the far infrared region you will be observing. Right students, these are the things. And you will be having a question. See, number of spectral lines that are possible from n is equal to 4 to n is equal to 1. Okay, how many lines are possible? See, from n is equal to 4 to n is equal to 1. This is one line. Directly it can come from 4 to 1. Or it can come from 4 to 3 and 3 to 1. Or it can come from 4 to 2, from 2 to 1. Or it can come from 4 to 3 or 3 to 2 and 2 to 1. These are the patterns of getting lines. Okay. So if you see, this is the single line. No repetition should be present. Here you have got the third one, 4 to 3. Not repeated, you are taking 4 to 1, next 4 to 3, here 3 to 1. Here 4 to 2, nothing repeated, next 2 to 1, okay. Here 4 to 3, see already here you are taken 4 to 3, here 4 to 3 again, so you can, among these two, one is cancelled. So this one is cancelled because it has been repeated. And 3 to 2, nothing is present there, so this can be taken into consideration. And 2 to 1, already it has been repeated here, you can cancel it. So 1, 2, 3, 4, 5, 6, so totally 6 lines you can get when an electron jumps from 4 to first. So instead of always drawing like this, you can use the formula. number of lines is n2 minus n1 into n2 minus n1 plus 1 by 2. So n2 we have taken 4 minus 1. Okay, 4 minus 1 it is 3, and 4 minus n1 is 1 plus 1. So it is 4. 1 is cancelled, 4. 3 into 4 by 2, 6 lines. So these two are correct. This is by using formula. So in the same way, 5 to 1, 5 to 3. So you can get the lines in this pattern. This is what for today, students. Have a nice day. Prepare well for the exam. Up to here, this is the syllabus for your examinations. Okay, students. Bye bye.